Hello everyone, my name is Albert. Today I'm very excited to present you how I did my legendary Titanic machine learning competition. In 1912, Titanic sank after colliding with an iceberg. Out of the 2,200 people on the board, only 700 people survived. In this competition, I was given some passenger informations such as age, sex, ticket class, the fare they paid, cabin number, and I was also given if that passenger survived or not. Now my task is using the existing information to build a machine learning model to predict if a new person came on board, would that person survive or not. Okay, let's get right into coding. Okay, first of all, let's do some data analysis. Import some libraries. NumPy, Panda, and Matplotlib is mostly for charting. Scikit-learn is a machine learning model. Import the data. As you can see, we have many columns, passenger IDs, P class, if a person survived or not, that's very useful. And we have multiple X's, including the name, sex, age, if a person has sibling or not, if a person has a parent or child, ticket number, fare, and cabin information. There are lots of steps I did to clean up this data. For example, I check if it's a duplicate, and I check if each column has missing values. In this case, we have age, cabin, and embark. All of them have missing values. What I decided is to drop the column, drop the NA row, drop some rows that has null values for the age and embarked. Also for the cabin, you have so many information that's missing. It's not going to be quite helpful for model building, so I decided to completely eliminate that column. So you can see after the cleanup, that's what I have, number of rows and columns. Then the machine learning also likes numbers, okay? Doesn't look like male or female, the SC and the letters. So I convert them into numbers. That's why I said change category data to numeric data. Then to check also if the data is imbalanced. In this case, we have about 400 people died and 300 people survived. So it's not that imbalanced, which is good. And this chart tells you, try to analyze some to see if the X has any relationship with Y's. For example, for all the survived people here, average age, median age is about 30. And then for the people who died, the median age is also 30. So I would say the age doesn't play a key role if a person survives or not. So do those similar exercise and analysis, and also see if there's any correlations, right, between X's and between X and Y's. At the end of the day, I have find, I show you here, sex plays an important role if a person survives or not. As you can see, sex 2 means females. More female, see, all out of all the females, many survived. Okay, for all the males, many male died. So I think sex is a key contributor. And also, if we look at the here, the P class, the class 1, which is highest class, in this class, more people survived than died. In class 3, the low class, more people died than survived. So that's the step 1. Just have a rough idea of what the data is telling you. not in a very detailed level, but in a rough idea. Okay, the next step we will do is to build the machine learning model. Okay, let's get to step 2, the actual modeling. First of all, you need to split the data and scale the data. You split the data so that the data have training data and test data. You can use this function, okay? So the reason why we do this is we will use the training data to build the model, but then we also need to test data to see how the model is actually performing. Okay, so we did the scaling, we did the splitting. Now we fitting the data to the model. In here, we fit the scaled X train data, which is a bunch of X's, and Y train. We fit this into a model, already in the model. And the model is called LG, right? The next step is evaluate the model. Now we have the LG model. We will use the X test data to generate the Y predict. Okay, so in this case, you can see what I predicted for the test data 0,0,0,0,0,1. You know, died, survived, died, survived. That's basically the predicted value. Then I measure the model performance accuracy, 80%, comparing the Y test. Y test means the actual, if that person survived or not. Y predict means based on my model, what is my prediction, and then like comparing the test and the prediction to see how accurate is my model. So in this case, I did 80% right. So I won't get into too details about this confusion matrix. It might be very confused for those people who are new to the machine learning model, but today's session is more about the high level steps. Okay, so overall, as long as you remember that we have to split the data, train the model, test the data, measure the performance, and now we get 80%, we're good. Okay. Hello, let's get to step 3, which is prediction. Now that we have the model, we need new data now. So the data that was given to me is those passenger informations, passenger ID, with their sex and age and siblings, the cabin number, you know, lots of them are missing, you can see. So, but anyway, the cabin, we are not using that information to predict Y, so we can just remove them. So I import the data, clean the data, right? So now it's almost look like exactly like what I put in the training data. But remember, in the new data, it still says male and female, and here is the letters Q, S, and C's. So I need to do the same thing as I did for the training data. Change them to 1 and 2, change all those letters to numbers so that machine learning model can read them. Okay, I scale the data. Finally, in 3.4, I use the model to predict Y for the new data. As you can see, we have total, the competition asked, give me 418 rows of data, all those passengers' IDs and all those information. And then I was able to add a column here to say if a person will survive or not. Finally, I just save that document to prediction CSV and getting ready to submit my number to the competition. Thanks. Okay, finally, I plan to use this Excel sheet to further explain the high-level process. So we have received the data here, survival or not, or the passenger informations, right? Then we use this information to build a model, y equal to fx. At the time, f is unknown. So we use the x, use the y, to generate the model. Secondly, then we use the model, the test data, right, which has the information, survival or not, use the model to generate the predicted Y. Then I compare the predicted Y with the actual Y to say if my prediction is right or wrong. So this test data, model testing, is used to see the model performance. Finally, when I'm giving the new data, you can see here, loss of X's, but I don't know if that person is survived or not. That's basically my task. Now that I know the F, the model, now we have the X, predict the Y. So I hope this make everyone clear how the model is built, how the model is tested with its performance, and how the model is used to predict new Ys. Thank you. Bye.